Lesson 6.5 is on applying systems of linear equations. In this lesson, you will determine the best method for solving systems of equations and apply systems of equations. So far we've learned graphing, substitution, elimination using addition, elimination using subtraction, and then elimination using multiplication. So we want to know when would be the best time to use each of these. So graphing, if you just need to estimate, graphing is a good way to do it. But if you need to get really specific and get an exact solution, graphing is not the best because it's kind of, I forget the word. But anyway, you could not get the exact answer. For substitution, you would use this if you have a coefficient of either 1 or -1 on one of your variables. For example, if you had like 2x plus y equals 3 and 2x plus 3y equals like 7, you have a coefficient of 1. So it'd be easy to get one of those variables by itself to then substitute it into the other equation. And then you could use elimination using addition. So you would do that if you have opposite coefficients in the two equations. So like if I have 2x plus 3y equals 4 and -2x plus 7y equals 5 or whatever, you have 2 and -2, so they were going to cancel out if you add those two equations together. You would use elimination if you had something like +2 here. So when you subtract it, then you would get 0. And you're going to use elimination when you have coefficients that are, wow, that's weird, that are not quite the same number. So that you would multiply one by the other to get the other. Okay, so if we're looking at this, we want to know what method would be best. So if we're going to use substitution, do I have a variable that has a coefficient of 1? I don't. So substitution might not be the best option. It's possible, but it's not going to be the easiest. Okay, so then elimination by addition. Do I have equal but opposite variables, coefficients on either of my variables? I have 2 and 4 and 3 and 2, so no. Do I have the same? No. So that means I'm going to be using multiplication or elimination by multiplication. So I want to get these to be the same, either on my x's or my y's. X is going to be easy because if I multiply my first equation by 2, I'm going to get them to both be 4. So I get 4x plus 6y equals 46. And my second equation, 4x plus 2y equals 34. So to solve this, I'm going to subtract the second equation from the first one. 4x minus 4x is 0. 6y minus 2y is 4y. And 46 minus 34 is 12. So then to get y by itself, you divide both sides by 4, and you get y equals 3. Once you have one variable, you still need to find the second one. You're going to plug it into one of your equations. So I'm going to put it into this second one. Doesn't matter which one. So from here I get 4x plus 6 equals 34. Minus 6 to both sides, I get 4x equals 28. So then x equals 7. So that means my solution is 7, 3. X, y. All right. For this one, first thing I'm looking for is substitution. Do I have a variable coefficient of 1? I do, right here. So this one I could use substitution. So to use substitution, I want to get the variable by itself. So x is going to be equal to 10 minus 2y. If I subtract 2y from both sides. Now I can take this and put it in for my variable x in my original. So I'm going to have 2 times 10 minus 2y plus 3y equals 17, and I'm solving from here. So 20 minus 4y plus 3y equals 17. So I'm going to get negative y, and when I combine those, it's negative y. And then subtracting 20 from both sides, I get negative 3. So then y is 3. Once I have y, I can plug it back in to my equation here to find x. So x is 10 minus 2 times 3. So 10 minus 6 is 4. So my solution is 4, 3, and the best method was substitution. Okay, Ace Car Rental rents cars for $45 and 25 cents per mile. Star Car Rental rents a car for $35 and 30 cents per mile. How many miles would a driver need to drive before the cost of renting a car at Ace Rental and renting a car at Star Car Rental are the same? So we'll say C is the cost. The cost of renting the car for Ace is $45, and then on top of that, 0.25 times the number of miles. For what's the other name of the one? Star Car Rental, it is 35 and then 30 cents per mile. So for this one, I want to know when these costs are the same. So since these are both C, this is already set up to do substitution because I already have a variable completely by itself. So that means what it's equal to, I can take and put into my other equation for the same variable. So that means I can say this is going to be 45 plus 0.25 m equals 35 plus 0.3 m. And I want to solve this. So I'm going to do minus 35 to both sides and minus 0.25 m. And so when I do this, I get 10 equals, this cancels, that cancels, 0.05 m. So to get m by itself, I'm going to divide both sides by 0.05. And so when I do that, 10 divided by 0.05, m is 200. So they would have to drive 200 miles in order for them to be the same cost. And that is section 6.5. Here's an extra practice problem.